Hello, welcome to a homework help video looking at some of the math questions from chapter 3. I'm going to start with question number 6 that says suppose that the overall efficiency of the conversion of chemical energy into coal and useful mechanical work of an electric motor is 29%. If the efficiency of the production of the electricity is 35 and the efficiency of the transmission of the motor is 85, what is the efficiency of the electric mechanical energy? And so these are three separate steps, and they basically gave us the answer to the problem in the 29%. And since it's in percentages, I'm going to use decimals, so this is 0.29. And that's actually my answer, is the 29%. And everything else is on the other side of my problem. So I'm going to write out the problem. Sorry, I gotta zoom in. I'm using my finger to write. It gets right too big. So that's this one. The other part is the 0.35 times the 0.85 times an arbitrary a. And in reality, what we're doing is we're solving for a over here. And so I'm going to work our way down. We're going to do this section first. And when I do that, I'm going to do is equal to 0.2975 times A. Next part is I'm going to move this side over to this side of my equation. Since this is timesing, it's going to be dividing when I move it over, so it's going to be 0.29 divided by 0.2975 is equal to A. And once I do that, I get 97.5% A. So this is my answer to my problem. And if I was to stick my answer in A into my original equation above, up here, if I was to put that there, my 97.5 into my problem, or 0.975, and I times the three numbers together, it should equal my 0.29. And so that's how I know I got my answer correct. And so this is question 6, and now we're going to take a look at question 7. So question 7 tells us to look at the table 3.5 on page 90, and I have a copy of that on the next skin. And it says the example is a conversion process of internal combustion engine and an electric vehicle. For both power systems, calculate the overall efficiencies. See the example in the first half of the table. So I'm going to flick over to where I have my table, and I've kind of circled in what we're going to do. But how we're going to do this problem is pretty simple. We're just going to work each section times its efficiency percentage. So I'm going to take my number and I'm going to times it by my next set. So I start out and my overall efficiency for my gasoline engine when I'm using raw fuel is 83%. To find out what my next overall efficiency is, I've got to do my timesing of my 83% times my 25%. The best way to also look at this example is right up here where they give us the example, where they give us the production of coal, and it is my overall of 96 at first, and so my overall efficiency is my 96. On the other hand, the transportation of coal is 97%. So I'm going to take my 96, or 0.96, and times it by my 0.97, and I'm going to get my 0.93, which is the answer we see right here. So going back to the problem down below, my overall efficiency is 83%. The engine efficiency is a step of 25, so what is my overall? 83%, or 8.3, times my 0.25. When I do that, I end up getting 0.2075, and since this is a percentage, I'm going to times it by 100, which will move my decimal over, and I'll end up with 20.75. So this is 20 0.75. All right, so now for the next step, I'm going to take my 20.75 and work my new efficiency, which is 70. So 20.75 times my 0.7. When I do that, I get 0.145. I can move my decimal over since it's going to be a percentage, and so I get 14.5. Once again, writing with my fingers, so it's a bit sloppy. 14.5. Next step is going to be taking my 14.5 and timesing that by the 70% that's here, so 0.7. And I get 1.06, 1.016. I can move my decimal over. My answer here is going to be 10.16%. So my final efficiency is 10.16%. So to answer the first part of question number 7, the amount of energy that I'm going to be using in my internal combustion engine, my ICE engine, is 10.16%. Now we're going to calculate the efficiency for the electric vehicle. So I'm going to do a little erasing, clean up my page. So once again, this time my overall efficiency is 96%. So I'm going to start with 0.96 and times that by my 33, so 0.3333 for my first part. And I get the 31.68, 31.68, 31.68, so 31.6. It's really all you need. All right, so for the next part, it's 90%, so I'm going to move my decimal back from where I had it and times this by 0.9. And I get 2.85, and I can move my decimal over, and so I get 28.5 for my next part. Next one is 80%. I can times this by 0.8. And I get 228. So once again, it's 22.8%. Next one is 90, so I'm going to times this by a 90% efficiency. And I get 205, so 0.205. So this is 20.5. And my last step is, I'm going to write over here, 2.05 times my 0.9, and I get 18.4, so 0.184, or 18.4%. So for the second part, the final efficiency reading for the energy used in the process of the electric car is 18.4 in its percentage. So this is how you do this table, and I hope this helps. And now I'm going to flick back to the other page and we'll just take a look at the last little problem that was kind of a math problem. So question 9 is also a little math problem. It says about how many BTUs of waste heat are dumped into the environment by fossil fuel electric generation plants that use 1,000 BTUs of chemical energy during combustion. And funny enough, the previous question tells you that the plants are about 35%. But if you looked it up in the table, you'll see that there was like a range, and you could have equated this in the range. But I'm going to use the 35% to just keep it easy. And so to do this problem, I'm going to take my 10,000 BTUs and times it by my 0.35, which is my percentage, which gives me 3,500 BTUs. Now this is the useful stuff. This is the useful energy. To get the not useful energy, I'm going to find out my waste. So I start out with 10,000 in my input, and I'm going to get a useful amount of 3,500 out, which means when I subtract my useful BTUs from my not to find out my waste, I get my 6,500 BTUs of waste. So this is my waste energy in BTUs. So just be careful, make sure you're answering the correct things. And that about covers the math portion or the math questions that were involved in the homework. I do hope this video helps. Have a good day. Enjoy your weekend. Bye.